Hello, in this video we're going to be looking at the marginal propensity to consume and save, which is the proportion of new income that consumers spend or save, and we're going to see how that fits in with the GDP multiplier. So marginal propensity to consume, or MPC, is the percentage or proportion of new income that consumers spend. So if you have a marginal propensity to consume of 90%, and you get $100 of new income, that means you are going to spend $90 of that. And likewise, you're going to save some of that. So if you're spending 90%, you're spending $90, that means you're going to save $10. Marginal propensity to consume is a function of your current disposable income. It's related to your expected lifetime income. So you might spend a much higher proportion of your income today if you think you're going to have a lot of money in the future. If you're concerned about your income in the future, regardless of how much you have right now, you might save more. Real wealth is also going to affect this. Remember, wealth is the value of items you currently own. So a house, a car, a phone, anything that you could sell and get money for. If you own a lot of stuff that's worth a lot of money, you might be willing to spend more of your income now. Sometimes consumers borrow to spend more than their current disposable income. So we can have a negative saving rate. If you remember from our aggregate expenditure model, we can have dis-saving. Consumers are spending more money than they bring in. And that can happen through borrowing. So to figure out our marginal propensity to consume, we're going to take the change in consumption divided by the change in disposable income. So it's not going to be your average spending of all your income. It's going to be the extra spending. So change in consumption divided by change in disposable income. So if we have an extra $100 per month in disposable income, or a lot of times in their book this is called Y or real GDP, and we increase consumption by $90. We would say our change in consumption is 90, we've got 90 extra, divided by that 100 extra of disposable income. This is going to give us a marginal propensity to consume of 0.9, or 90%. This is similar to when we looked at percentage changes earlier in the semester. If you get a value of 1, that means 100%. If you get a value of 0.1, that means 10%. The value of 0.37, 37%. 0.04 is 4%. So a lot of times people multiply this number by 100. You get 0.9 times 100, and then that's going to give you 90, right? 90%. There is a permanent income hypothesis that says temporary income changes are going to have less of an impact on spending than permanent income changes. If you think that an increase in your income is going to be forever, you're much more likely to spend more now. If you think it's temporary, you have $100 extra in your income, but you think it's just going to be for this paycheck, it's not going to be permanent, you might save it or you might not spend it all. If you think you're going to be getting $100 in every paycheck for the rest of your life, you're much more likely to spend it and spend it continuously. Sometimes governments use this information in determining how to send money back to households during recessions. During our fiscal policy chapter, we're going to talk about some different stimulus packages. One where it was a large lump sum versus a weekly payment. And we're going to see how that affects consumer spending. The marginal propensity to save is the extra income you get that you saved. Consumers who have borrowed have a negative saving rate, or a marginal propensity to consume that's less than 1. So marginal propensity to save, or MPS, is equal to the change in saving divided by the change in disposable income. So let's say we have $100 extra of disposable income. We have $90 of extra consumption and $10 of extra saving. So if we're calculating our marginal propensity to consume, we would say 90 divided by 100.9. For our saving rate, or our MPS, we would say 10 divided by 100. We get an MPS of 0.10. So what this says is that every extra dollar we get, we are going to save 10 cents of that, or 10%, and we're going to spend 90 cents of that. In our aggregate expenditure model, this amount is going to be constant. So we're going to have that aggregate expenditure line, and the slope of that line is determined by this marginal propensity to consume. And so we're going to say it's constant over this entire line. And it can change, so it does change in real life, and it might not be constant. But for the purposes of our model, we're going to pick one point in time, figure out what the MPC and MPS are at that point in time, and then we're going to plug that into our aggregate expenditures model. MPC plus MPS is always going to equal 1. So 0.9 plus 0.1 equals 1. What about if we have consumers who are borrowing? So let's say we have a consumer that's borrowing 12%. So their marginal propensity to consume is actually 1.12. So MPC equals 1.12. What does that mean for our saving rate? Well, it means we have a dis-saving rate. Okay, so it means our marginal propensity to save has to be negative 0.12. Because when we add these two together, it has to always equal 1. If we have dis-saving, negative saving, it's going to be equal to whatever that extra consumption is. If we have marginal propensity to consume of 0.7, then our marginal propensity to save must be 0.3. Because when we add these together, they have to equal 1. It has to equal 100%. And so now we can use this MPC or MPS to look at our GDP multiplier. It's actually determined by the proportion of consumption and saving. So in our GDP chapter, we looked at what is, the change in total GDP divided by some sort of change in initial spending. And here we can see that the multiplier, or this proportion, is actually determined by what percentage consumers are spending and what percentage they're saving. The multiplier is going to grow as the MPC gets larger and the MPS gets smaller. So the more consumers are spending, the higher that multiplier is going to be. And the larger the spending is, or the smaller consumption is, then the less that multiplier is going to be. So we can actually calculate the GDP multiplier using the number we get for the MPC or the MPS. So our standard formula is going to be 1 divided by 1 minus MPC. We can also rewrite this equation as 1 divided by MPS. And we can do that because we have that equation where 1 is equal to MPC plus MPS. Okay. So if we subtract MPC from both sides, we get 1 minus MPC is equal to MPS. And so we can put either of those things on the bottom equation. So we can plug that in, we could figure out what the size of our multiplier is. Okay, so let's look at an example. So we're going to have an increase of $300 in aggregate expenditure. That's going to cause our equilibrium real GDP to increase by $1,500. This is going to be a $300 autonomous increase in spending. So this is going to shift our curve up vertically by $300. So you can look here where our aggregate expenditures hits our y-axis. And you can see we start at $1,400. We shift this upward by 300, and so now we start at $1,700. So we have a vertical shift of $300. Now, because of our multiplier effect, this $300 change in spending leads to a much greater change in our equilibrium real GDP. So we can see that where our original curve hit that 45-degree line, we get $7,000. And then where our new shifted up aggregate expenditures line hits that 45-degree line is now at $8,500. So our equilibrium is going to increase by $1,500. $1,500 more in income, $1,500 more in real GDP. And that is because of this multiplier effect. Now, if we were doing this from a few chapters ago, we would say 1,500 divided by 300. So the total change divided by the initial change. And this is going to give us a multiplier of 5. But we want to see how we can actually do that using the MPC. So the slope of this line, the slope of our aggregate expenditures line, is related to that marginal propensity to consume. So we're going to get some sort of function. So we're going to have our aggregate expenditures function, and it's going to have some sort of autonomous level of consumption, some kind of autonomous investment, autonomous government spending and net exports. But then we're also going to have induced expenditures, which we talked about in our first video about aggregate expenditures model. And so in this example, our autonomous expenditures were $300 for consumption. And then we got a bunch of other stuff here, which all of this totals $1,400, so I guess this is $1,100. And then we got plus 0.8y, meaning any new increase in income or any new increase in real GDP, our consumers are going to be spending 0.8 or 80% of that. And so the example in this chapter has a marginal propensity to consume, an MPC, that's equal to 0.8. So our MPC is equal to 0.8. And this is also going to give us a multiplier of 5. Okay, so let's plug that into our equation. So from our last slide, we have our multiplier, which is 1 divided by 1 minus the MPC. So 1 divided by 1 minus 0.8, okay, which is going to be 1 divided by 0.2, and then that gives us a multiplier of 5. So if we know the proportion that consumers spend, and we know the initial increase in spending, we're always going to know what our new equilibrium GDP is. So in this case, if we had another $100 of autonomous spending, it's going to increase real GDP by 500. If we have $700 increase in autonomous spending, that's going to lead to $3,500 increase in our new equilibrium real GDP. So as long as we know that MPC, we're going to be able to figure out that multiplier and the final change in real GDP. Now remember, this is representing per year. Okay, so this is representing an entire year period. And so this increase in consumption or investment or whatever this $300 increase was, is going to happen one time during the year. It's not a continual increase. It's, businesses decided to increase investment by $300. But what's going to happen is over time, during a whole year period, that money is going to be spent more than once until finally it results in this new higher level of spending. We can also see how different levels of MPC, or different rates of spending and saving, are going to affect this multiplier. Okay, so it's not always going to be 5, right? It depends on that value here. One thing to notice here, one minus 0.8 is the same thing as 1 divided by 0.2. So 1 divided by 1 minus 0.8 is 1 minus the MPC, which is equal to 1 divided by the MPS. Just make sure when you're doing this, you remember which thing to put on the bottom, because you don't want to forget and just put 1 divided by 0.8, because that would give you the wrong answer. So just make sure you know which thing is your saving rate, which thing is your consumption rate. Okay, so we have an MPC of 0.8, multiplier of 5, and then we get that by plugging that number in. Okay, so let's look at this example here. We have an increase in $5 of income. So some total change or initial change in income. And in this example, we have a marginal propensity to consume of 0.75, which means we have a marginal propensity to save of 0.25. So when my consumer earns this $5, they spend $3.75, and they save $1.25. Now this money that they spent is going to turn into income for somebody else. So let's say they spent this money at the coffee shop, and the barista now gets paid $3.75. We're going to assume that that barista is now going to spend 75% of that and save 25%. So they spend $2.81 and they save 94 cents. This $2.81 that they spent becomes income for someone else, who then spends 75% of it, saves 25%. This becomes income for someone else, and so on and so forth. And if you continue doing this all the way down, for infinity, you get to a point where the total amount spent is going to be $15, and the total amount saved is going to be $5. And we can get that with our multiplier. So we would say 1 divided by 1 minus the MPC. So in this case, it's going to be 1 divided by 1 minus 0.75, okay? Or 1 divided by 0.25. Plug that into your calculator, and we're going to get a multiplier equal to 4. So when we look at the total change in income in our economy, we see that it's $20. So we started with $5. We multiply by 4 from calculating our multiplier here, and we see that we have a total change in real GDP equal to $20. On this chart, this is showing you how the MPC relates to the multiplier, but you can calculate this for any number. So if we have a marginal propensity to consume of 0.9, 1 divided by 1 minus 0.9 is going to equal 10. MPC of 0.8, 1 divided by 1 minus 0.8 equals a multiplier of 5. Okay, so notice we just went from 90% to 80% spending. That does not seem like a huge cut. People are saving 10% more, but it cut that size of the multiplier in half. So it makes a really big difference. And when the government is trying to stimulate the economy, they really want to get that MPC up as high as possible because it's going to help the economy get out of the recession faster. Or during times of high inflation, they really want to cut that MPC, and they don't even necessarily have to have huge cuts, and it can make a big difference in inflation rates. 0.75, right, is going to give us a multiplier of 4. 0.67 is going to give us a multiplier of 3. And 0.5 is going to give us a multiplier of 2. So even small changes in that saving and spending rate is going to give us potentially a big change in the multiplier. So marginal propensity to save, marginal propensity to consume are very important in how quickly your economy grows or shrinks and how effective government policies are going to be at expanding or shrinking the economy.